I'm going to do a quick video on the counting principle. The counting principle basically states if you can do something m ways and something immediately following n ways, the total number of ways you can do something is m times n. And that probably doesn't make a whole lot of sense to you right now. So let me explain. Let's say I went out to eat and there's two appetizers and there's three main dishes. And this is a lovely blue. I might actually stick with this. Well, and then there's four desserts. I should have stuck with the other blue. Well, if I wanted to find out how many different combinations or how many different um, three-course meals I can make, I'll just take 2 times 3 times 4, and that's 6. That's 24 different ways. Now I'm going to actually show you why this works. So let's go back to my green. I had two appetizers, and so let's say I had soup or I had salad. And then I had three mains, all right? And I like that blue better. So let's say I ordered the soup, and then I had a veggie, a fish, and a meat. Well, if I had ordered the salad, I could also have the veggie, the fish, or the meat. And let's do, well, this looks like a nice purple. And then for my desserts, I had four different options. So let's say I had a tiramisu, creme brulee, ice cream, or I don't know, a chocolate brownie. All right. Well, each one of these would have those four options. And I think the hardest thing for students in understanding this is, besides my terrible handwriting, is that each one of these end branches is the entire option. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So if I took a look and said, all right, it's tiramisu, creme brulee, ice cream, brownie, tiramisu, creme brulee, ice cream, brownie, tiramisu, creme brulee, ice cream, brownie, etc., etc. Oops, I went in the wrong order. That's fine. Um, so if I wanted to find the probability of ordering soup and fish, well, I'd go down the soup line, and then I'd follow the fish line. And you might say, oh, that's 2. Well, that's true, but it's really, you also then had 4 different options, so it's really 4 out of 24, which is 1/6. Because although soup and fish is really only one option, we're having a 3-course meal, so there's 4 total ways you can order the soup and fish. Soup and fish and tiramisu, soup and fish and creme brulee, soup and fish and ice cream, and soup and fish and brownie. Um, if I said the probability that you had soup or meat, it gets a little tricky because soup is going to be all of these, all of these, and all of these, which is 4, 8, 12. And then the meat, you don't count these twice because we've already counted them for the soup. But if I ordered salad, I could also order meat. And then I'd have 4 more options. So it'd be 4, 8, 12, 16. It'd be 16 out of 24. And I'm going to do that with my pencil here. Soup includes, oh, I thought this was supposed to be a pencil. Nope. I don't want that. Goodness me, I don't like any of these options. these are all the soups. And then this branch here includes the meats. And so you can see 4, 8, 12, and then 16. But it's all so messy. I'm just going to erase all of this. Oh, goodness me. Oh, look at it all going away. Alright, that's what I wanted to get rid of. Alright, so I'm going to go back. And then she said, what's the probability of ordering a salad and veg and tiramisu? Well, these are all ands, so there's only one way of getting salad, veg, and tiramisu. That'd be 1 out of 24. Now, I want to say one other thing about the counting principle. Sometimes tree diagrams are not super useful. Actually, many times tree diagrams aren't very useful. If I were to do something like rolling 2 dice, for example, I might do 1, 2, 3, 4, 5, 6. 1, 1, 1, 1, 1, 1. 1, 2, 3, 4, 5, 6, and then 2, 2, 2, 2, 2, 2. And what I'm doing right here is I'm making up all the possible ways I can roll 2 dice. And you might be wondering what on earth this actually means. It means the first die is a 2, and the second die is a 2. Or the first die is a 2, and the second die is a 3. I was just talking to Sarah about this, and I said I was always confusing as a student to think of, when I did this, thinking of the dice as 2 separate numbers, but they really are. So the probability of rolling a 3 and a 5 is really the probability of rolling a 3 and then a 5, or a 5 and then a 3. And that actually happens twice. So it's 2 out of 36. And that should make sense because there's 6 ways of rolling one number and 6 ways of rolling another number, so it's 1 out of 18. If I wanted the probability of rolling a 7 or an 11, that I'll rewrite this. 3, 5, 5, 3. So if I wanted the probability of a 7 or an 11, I've always liked this one. I would take a look. I'd say, all right, well, how do I get 7? It ends up being this diagonal here. These are all 7. And then 11 is this small diagonal here. And you can see there's 1, 2, 3, 4, 5, 6, 7, 8. So the probability of 7 or 11 is 8 out of 36. That reduces down to 2 ninths. All right. And the very last thing I want to say is, if you had a coin and you flipped it heads or tails, and the probability of getting a head is 1 out of 2. Probability of getting a head and a head is 1 out of 2 times 1 out of 2, which is 1 out of 4. Probability of getting a head 6 times in a row would be 1 half times 1 half times 1 half times 1 half times 1 half. 1, 2, 3, 4, 5 times 1 half, which is really 1 over 2 to the power of 6. Just something that you should keep in mind. And that's it. So I hope this video helped you in your journeys.